then we're going to get back to our embedding model. Today, I want to do a lot of things with it. I've got a plan. Got a plan. At everyone. Ooh, we did a new one. Hey, how's it going there? Welcome on in. Jack Ishifer. Good to see you. Oh, Torva, thank you, Torva. You got the link. You got the link. You did it before I did. Thank you, Torva. Hey, how's it going? Welcome on in. Happy Wednesday. Good to see you. We're going to continue our embedding model. We got most of it done yesterday. I think what we've got is the nice foundation. We've got a really good foundation that is going to allow us to start training. We're going to try to train it. And I think we also need to measure it, and we need to visualize it. There's a lot of stuff to do. Wouldn't it be nice to have the AI just do that for us? At this point, maybe to write the code for us a little bit. I think that would be really nice. All right, what do we need to do here? So we did the norm layer, already dividing by the number of words, linear, done. Linear layer without bias, we did that. Do we need this? Do we need these things is the next question. I think the answer is we do. We were told that we don't need them. However, I'm pretty sure we might need them. I think just maybe. We're going to find out though. What's the number of words on the output, right? So that we've got defined here. It's actually pretty straightforward because there's not a lot of code here. It's only 100 lines, roughly 100 lines. We could walk through it right now. Let's do a full walkthrough of what we've currently got. So that way we can figure out where we want to go from here because there's a lot of tasks that we got to use. You should use a location-based model. Ooh, Jambuster, or a data set. That would be pretty neat. What I'm using is this data set right here. It's a little simple sentence, right? Set wrap. You can see a very small, very easy, simple sentence. That's an easy one right there. Super easy, super simple. So let's go through where our embedding model is. Congratulations, you guys, though, who got the memberships. Lil Wayne, hey, how's it going? Good to see you. Welcome on in. All right, so where are we at right now? So we got our embedding model. We did, thank you to Dina. We need to do some of these things here. So here's our embedding model. It's fairly easy. Here's right here. This is our embedding layer. Look at that. Look how simple that is right there. That's all it is. It's just a matrix. It's a 2D matrix. Let's do a quick walkthrough, then we're gonna watch the video. So here's our embedding in it. We've got the number of words and our dictionary. I'm storing these in here. It's not traditional for an embedding model to do this. I'm doing this on purpose because we want to use a lot of the metadata that's around this. I need the length of the dictionary, number of words, and the ability to look up, right? Because I'm gonna tokenize. I want my feed forward to include pre-vectorized data, right? It's gonna allow you to post in just any words directly. So you can pass in this entire sentence. That's why I did that here in the feed forward, the forward pass. Then we're going to do a lookup based on all the features are going to include the index of all the IDs that we are going to need to capture the output from our embedding. The embedding is going to return rows that are assigned to each of the indexes in our IDs. That's what that is. And then we have a whole bunch of data manipulation code here that we needed in order to get it to operate properly. That's what we had to do. We'll walk through that here. We're teaching Pytorch right now with Python. And as you can see on the screen right here, there's not a lot of Pytorch. This is because the majority of the work when it comes to AI is data management and data preparation. Happy coding. Thank you. I am Harry for mentioning it. What is a tokenizer? Oh, what tokenizer are you using? My very own. I'm using my own. It's all from scratch, you guys. So the tokenizer is actually kind of see it right here. Really simple. So we normalize our words, which you see right here, normalize right here, which is a simple normalization. And then we capture our normed words. Then we throw it into our dictionary, which we pre-calculate our dictionary just by building it based on all the data set of the words. So this is a dictionary calculator, which is just a Python dictionary. It's actually a dictionary with a word followed by the word index, right? And what I should do here is I shouldn't use the word pad. I should throw some other word in here. I should say pad like this. It's got to be caps. It's got to be in caps. Found a little bug there. Nice little bug there. We still want to get to my embedding model here because we got to the point, Neva, if you're curious, we've got the full feed forward pass working. Now all we have to do is leverage our optimizer and our loss function to back propagate crater gradients and apply the optimal weight updates. Default tax rate value of 19%, but you can get that refunded if it's not for business. 19% is a lot. Also, how do you get that refunded if you go to the grocery store like every day? That would be a lot of paperwork. You keep telling you, Stephen, embedding is trained alongside a large language model, not separately. Yeah, so I'm going to try. That's why I think I've got these. I left these here. Right, I left these here. So this needs to be, what is that? 256. And then this will be 256. Maybe then 256, 128, 128, and the number words. 28. So I'm gonna try. It's okay. What's our shapes here? So I need to compare the shapes. Is what I need to do. Features, labels, shapes. I want the out shape and the label shape here. Let's hide everything else, and then we need to do a break. Just one, you guys. Let's do just one there. All right. So we get 23 and 32. The label. So since we're doing all the words, we're getting a batch. Oh. How are we going to deal with that? So we need a reshape. We got to do a reshape here. Something's broken here. This should do the trick. What is it? So hold on. Print Lin dictionary. It is 23. So then why is this 32? Right here. Why is that 32? We need to figure that out right there. We got to figure out why is it 32. So I need to get the loss working, and that should be at least the one last thing that we do today. I need to get the loss successful. And I think I can do it right now, basically. So this will give us a number of words. Let's go ahead and run that on the output once. And the number of words is 23. The output size, 23. There we go. Let's double check this here. So so let's see. Out.shape. Let's see the out. And then we've got our label. And we got our label shape. There we go. Then we'll get the dictionary length. So that way, this is gonna make it a little bit easier to see what's actually what we're printing on the screen. You know, we're gonna see what we're printing on the screen. Let's see here, you guys. Just log the prob classic cross entropy. Yes, that's the idea. Okay, dictionary length 23, perfect. Label size 23. There we go. Output size 32. Why? What? Hold on. That seems broken to me. So so I've said features, right? So that's fine. That part's fine. We're good there. We're good there. So since we're inputting that number of features, my edit after the after effect. I just need to fix this one last thing here. I need to at least get the loss working. The output is 32. So why is it doing that? Let's see here. Oh! You should say Steven. It's because you didn't write it yet. You didn't write it. You didn't write it. Size 32. So we need that 32 to be a 23. But why is it 32? It's just weird that it's 32. It shouldn't be. Right? Why would it be 32? Because we're only doing the embedding. So this is going to give 3. It's going to be the exact vectors that I'm looking for, which is fine. So that gives me the features from my vectors, which is perfect. Or is it? Yes. So I get my tokenization, right? It gets me all my words, which is going to be 1, 2, 3. And then I do a forward pass. See, I could probably do like, maybe do dot squeeze. Or maybe we do a squeeze. S-Q-U-E-E-Z-E. Let's try that. That did not do anything. That did literally nothing. C1. Expected a range between -1 and +1. Okay. Dim equals. Maybe I need to unsqueeze it. Oh, it's... There we go. Didn't like it. Didn't like it. Okay. Okay. So that's the wrong direction. Though, it changed some things. Let's see, -1. All right, here we go. No, well, no, it still didn't give me what I'm looking for. We need to get the right shape, you guys, because our dictionary is going to be the answer. The dictionary is going to be the answer, not the number of words. Do we even need this? We don't. We just need the dictionary. So let's fix this. Let's see, where are we getting number of the words? Let's build the dictionary, and we won't return. Oh, we already are returning. We'll just return dictionary. We don't need number of words anymore. There we go. And we will only, in the embedding model, request the dictionary. And then we can just do a length over this for the dictionary itself. There we go. So now we've got number of words. Let's see here. All right. And then this should do the trick. So that's the input shape. So maybe that's why we're seeing a problem right now. That might be what the problem is. Here is my edit, but the intro lagging. Okay. Whoa. Is there anything safe for work here? Here, I'm gonna mute it. I'll mute it. Hey, you're doing some video editing. Nice. Where's the invite though? Optional. The invite. The shape of the feature. That shape. See what that looks like. All right, here we go. Number of words. All right, number of words. It's gonna be up to self. And then there we go. That should be, I believe it should be 23. It should be 23. It shouldn't be anything less. Shouldn't be anything more. It should be 23. All right, build dictionary. All right, how about now? Okay. Shape 3-1. Okay. And then our output size is 32. Let me go back over here. Let's undo this here really quick. I would like to try something a smidge different. Let's just do one at a time. We'll do one at a time here. Let's see. Length. Let's see. What do you call this here? Length. Length. L-E-N-G-T-H. We'll say 1. I'll just update these guys real quick here. Okay, I think that's it. So now I can customize that a little bit better. Let's try that now. Size 1, 1, 1, 1 looks good. I pass it through, and then it gives me an embedding the size of 32 to 256. 32. Where is it getting 32 from? That's what my question is.